Hello, class. In this video, we're going to talk about determining the properties of the given secant function. I misspelled that. That was supposed to be secant, but nevertheless, secant and tangent functions have a lot in common. Remember that in terms of the unit circle, tangent is y over x, while secant is 1 over x. They have the same denominator, and through our investigation, we found they have the same vertical asymptote location. So we'll go ahead and start with the transformations. We're talking about a vertical compression by 1/3. Okay. That's one of the vertical changes, and we are also moving it down 1. All right, now for the horizontal ones, we have a horizontal compression by 1/4. And now when we see that we have a left shift, we have to factor out our 4. So pi divided by 2 divided by 4 would be pi over 8. Oh, there we go. All right. So we're going to look at the period first. Now remember that secant has a period of 2 pi, and we're multiplying it by 1 over 4. So that would give us 2 pi over 4. And then simplify that, that's just pi over 2. So our period is pi over 2. Okay. Now, looking at the vertical asymptotes, our initial vertical asymptote, again, is always the same as the tangent one. It's pi over 2. And we're multiplying by our period of pi, or sorry, not by our period, by our, we're going to multiply by our horizontal compression. So that's 1/4. And then we're going to subtract. There we go. Minus our shift to the left of pi over 8. Now, just some real quick computations. Pi over 2 times 1/4, or times 1/4 minus pi over 8, that'll all give us 0. So when we write out our vertical asymptote equation, usually we start with the initial value, and that's 0 in this instance, but adding 0 to anything is going to be itself, so we won't write it. Now, the thing we have to remember is that the period of which vertical asymptotes repeat for secant will always be half of what the original period is. So that means this pi over 2, we have to cut that in half. So pi over 2 times 1/2, that's pi over 4. We have to remember that the reason for this is because while our period is 2 pi in the original graph, the graph looks like this, where we have a U shape, and then the very next instance is an upside down U shape. Well, in between that is a vertical asymptote. But this is one period, and yet before that we'll have a vertical asymptote. After that we'll have a vertical asymptote. And from here to here is 1 pi, whereas the length of the whole thing is 2 pi. So we always have to remember the vertical asymptotes repeat half of what the period is. This is the one minor difference we have to worry about when doing secant versus tangent functions. And then from there, it's pretty simple. The domain is x does not equal pi over 4n. Now the range, we actually have to do some calculations. Remember, our initial range is -∞ to -1, union 1 to infinity. So we're going to calculate this like we do sine and cosine. We're going to take -1. We're going to multiply by our vertical compression and then subtract 1. So -1 times 1/3 is -1/3 minus 1 is -4/3. And then we have a +1 times 1/3 minus 1 is 1/3 minus 1. That's -2/3. 2/3. Now, usually you're going to identify whichever one's the smallest one and put that one first. So in writing out our final answer, it's negative infinity to negative 4/3, and then union negative 2/3 infinity. And that's what we have. So go ahead and take the time to try the you do on your own, and then the answers will be given to you in the questions, and then we'll move on to example 2. Okay, so let's try one more problem. Determine the properties of the function. So let's again start with the transformations. We've got a reflect across the x-axis. Okay. We have a vertical stretch by 2. Try and change colors this time. Okay. There we go. And we don't have anything on the inside except we're moving right 5 pi over 3. Not bad. All right. So period. The period of secant, again, is 2 pi. But since we don't have any horizontal stretch or compression, that's going to remain the same. So we don't have any calculations to do there. So I'm going to go ahead and just erase that so we don't need it. Now we're going to have to get our initial value. So now that's just pi over 2. We're moving right, but we're not multiplying by anything. So it's just plus 5 pi over 3. Well, we're dealing with fractions here, so let's get our common denominator of 6. So we got 3 pi over 6, plus 10 pi over 6. That gives us 13 pi over 6. So our vertical asymptote will be x equals 13 pi over 6. And then we're adding half of our period value. That'll just be pi n. And that gives us our domain as well. X does not equal 13 pi over 6 plus pi n. All right, so let's go ahead and look at the range. So again, we'll start with -1. And this time we're just multiplying by the reflection and the vertical stretch. So it's times -2. Probably didn't need to write it down, but what the heck. That's a +2, and then we have a +1 times a -2. That equals a -2. So I'm writing out my range. I got a negative infinity to a -2. Smallest one comes first. Close with the bracket. Union 2 to infinity, and we're done. Go ahead and give the last you do a try. All right, now go ahead and give the exit ticket a try.